questions for the electricity test that you're going to have on Wednesday, December the 12th. These are some questions that we might find in the test. First question is, draw a schematic diagram with a battery containing 3 cells, 2 volts each, and 2 lamps in parallel. Each lamp has its own switch. The circuit also contains an extra switch to turn everything off at once. And I've given you a constant that you might use later on for calculation. So the answer, here you have a battery with...
Mr. Curran, please come to the library, Mr. Curran.
Here we have a battery with 3 cells. Each cell is 2 volts, so that's going to be a total of 6 volts. The conductor goes through to a switch. This switch is closed, so the current can flow that way. If you open this switch, both of these will go off, so the whole circuit will be turned off from this switch. Then there's separate switches for each one of the lamps, and of course they're in parallel, meaning that the current can take 2 separate paths. In the second question, we're asked what is happening in this circuit, which is shown in this schematic diagram. And the answer to A is nothing, because the switch is open. So you can't have current flowing if there's an open switch. The circuit is open, no current is flowing. B, they ask label the cathode and the anode. A trick you can use to remember what the cathode and the anode of a battery is to use a little mnemonic. Remember that first of all, cations are positive. Think of cats having paws. So if a cat has paws, the cations are positive. You can also remember that the cathode attracts cations. Cations are positive. What do you need to attract something that's positive? You need something with a negative charge. So the cathode is negative. The negative side of the battery is the cathode, and it's represented by the shorter line in the cell. On the other side, you have the anode, which attracts anions, and that's the positive side of the cell. So we've labeled the cathode and the anode. I say as the answer, cathodes attract cations, which are positive because the cathode is negative. Anodes attract anions, which are negative, because the anode is positive. In question C, if the switch is closed, what is the current? So here we close the circuit. What happens? You have 40 volts, and the resistance here is 5 ohms. So we're going to use Ohm's law to calculate V is equal to IR. We're trying to find the current, so we're going to arrange Ohm's law to find I. So we do that by transposing the R, putting it under the V. I is equal to V over R. Enter the numbers, 40 volts over 5 ohms, we get 8 amps. Now the definition of amps is a current flow of 1 coulomb per second. So a 1 amp current has a flow of electrons of 1 coulomb of electrons per second. And 1 coulomb is 6.24 times 10 to the 18 electrons. Actually, it's 6.24 times 10 to the 18 charges, because you can also have a coulomb of positive charges. But typically we think of electrons. Electrons are the things that move. Positive charges don't move because they're associated with the nucleus of the atom. So we're asked in this question, how many electrons will flow in 2 minutes if the switch is closed? We recall that 1 amp is equal to 1 coulomb per second, that there are 6.24 times 10 to the 18 electrons flowing per second in a 1 amp current. Because the current is 8 coulombs per second, being 8 amps, and there are 60 seconds in the minute, and the circuit is closed for 2 minutes, we get 960 coulombs. 960 coulombs times 6.24 times 10 to the 18 electrons per coulomb gives us 5.99 times 10 to the 21 electrons. In the next question, we have a hairdryer operating at 120 volts. It draws a current of 12.5 amps. What is its resistance? We again use Ohm's law. The 2 arrows point out the 2 things that we are given. We're given the voltage, we're given the current. We want to find the resistance. So we rearrange the equation. We transpose the I. So R is equal to V over I. We get 120 divided by 12.5. When we plug in the numbers, the answer is 9.6 ohms. Number 4, what voltage is needed to push a 10 amp current through a 1,000 ohm resistance? So that would be a pretty high resistance. And 10 amps is a fairly substantial current. So we're going to find out VSU IR again, we're gonna use Ohm's law. We plug in the two numbers that we do have to find out the one that we don't have. 10 amps times 1,000 ohms is 10,000 volts. So you need 10,000 volts to push a 10 amp current through that much resistance. Likely you would get a lot of heat being generated as well, so it's not very practical. Well, if it was a heater, that's what you would use it for. Number 5, what is the current in this circuit? How many electrons pass through it in 1 second? Notice how I've pointed out what's being given. And you should develop the same ability to find out what it is that the question is giving you in terms of variables. So I've pointed at the variables that you do have with arrows, so that way you can see more easily which one you don't have. And that way you know how to rearrange the equation after. So we have a schematic diagram here with a 6-volt battery and a lamp that has a resistance of 0.2 ohms. So we're asked to find out the current flow in this circuit. So we rearrange Ohm's law, V over R gives you I, then you plug in the numbers. 6 volts divided 0.2 amps gives you 30 amps. And then how many electrons pass through in 1 second? Remember that 30 amps is the same as 30 coulombs per second. 30 coulombs times 6.24 times 10 to the 18 electrons per coulomb. Coulombs cancel. 1.872 times 10 to the 20 electrons would pass through that circuit every second. Any questions? No. Okay, we'll stop there.